Now, let's talk about one of the key rules associated with present worth analysis. And that rule says all alternatives must be evaluated over the same time period. And we call that time period the analysis period. It's the planning horizon or the project life. These are all different terms that we use. For example, in this problem, the analysis period was 5 years. And you notice that we compared them over 5 years. So it was an apple to apple comparison essentially. Now, the length of the planning horizon really depends on the industry. If you're comparing multiple investment opportunities in a rapidly changing technologies such as the tech industry or maybe entertainment industry, those planning horizons are rather short, maybe 5 years or so. But then we have stable technologies or industries such as steel making, for example, and in those situations, investments are compared to each other over a longer planning horizon, 10 to 20 years. And if it's government agencies that they invest in major projects with longer lifetime, the analysis period it can be 50 years or more. Well, on a good day, when you're comparing multiple alternatives and all the information are given over the same time period, it's perfect. But what if the useful lives of these alternatives differ? Basically, one alternative has a useful life of, let's say, 7 years, and the other has a useful life of 14 years, for example, or 20 years. What do we do with that? Well, there are two methods to resolve this problem. The first one is we can use the least common multiple of their useful lives. For example, if you have a 5-year project and a 10-year project, we would just use the 10-year analysis period, but we just have to accommodate the 5-year project. And what we're going to do is we're going to assume that for the second 5 years of the analysis period, the cash flow of that alternative is just going to repeat for another 5 years. And that's a very simple scenario. Or if finding the least common multiple is difficult or results in a really long analysis period, what we can do is we can choose an analysis period that is not necessarily equal to any of the alternative lives. Right? Let's take a look at one example for that. This example, we have a diesel manufacturer that is considering the two alternative production machines with the following cash flow information: the initial cost of those two machines and the salvage value of those two machines at the end of their useful lives. And what we can see here is the useful lives are 7 years and 13 years. The manufacturer used an interest rate of 8% and wants to use the present worth method to compare these alternatives over an analysis period of 10 years. So they want to compare them over 10 years, and it seems like they're in the somewhere between rapidly changing technologies to stable technologies, where 10 years seems to be a good analysis period for them. So for this case, the analysis period is 10 years and is not equal to any of these two. What we need to do is we have to estimate the market values of these alternatives at year 10. The market values at year 10 must be estimated. Alternative 1 will be 3 years into its second life, right? With value of $20,000, and alternative 2 will be nearing the end of its first life with value of $15,000. And these values are essentially estimated market values at year 10. The estimated market value of the alternative 1 is for the second purchase of that machine, and the estimated market value of the alternative 2 is the worth of that machine at the end of year 10, although that machine still has another 3 years to go. So let's get everything on a cash flow and compare these two. So here we have alternative 1. You purchase the machine at year 0, and then at the end of year 7, you sell it for the salvage value, and it seems like the salvage value for that is $10,000. And then you would have to purchase that machine again. So the same investment occurs. And then you get to year 10, then you sell it for the terminal value that is estimated. And that terminal value is the $20,000. And after year 10, we don't even consider anything after that. For alternative 2, you make the purchase, and at the end of year 10, you have a terminal value, and that is $15,000. So that's a little easier cash flow here. But the most important thing here is that those estimations enable us to compare them over 10-year analysis period. So 10-year analysis period is what we're going to use. So what we need to do here is to calculate the present worth of these two cash flows. The initial costs are already in the present time. What we need to do is we need to take back the salvage value to times 0, the replacement cost to times 0, and the terminal value to times 0. And for the second alternative, we just need to calculate the present worth of the terminal value. And that's what's happened here. For alternative 1, we have the initial investment. And then at year 7, you sell the first machine for $10,000, but you would have to purchase the second one, and that's a negative $50,000. Then at the end of year 10, you have the terminal value of $20,000. And because these are only one-time benefits or costs, we use the P given F factor. You do the math, you get about negative $64,000 as the net present worth. In this case, is actually all cost because it's negative. For alternative 2, you have the initial investment of $75,000, and then at the end of year 10, you sell that for the terminal value of $15,000. You need to compute the present worth of that using the P given F factor, and that will give you the present worth of negative $68,000. Well, here you can see that you got to pick the one that is less negative or more cost effective, and that is alternative 1. So this is essentially what needs to be done when the useful life of alternatives are different and you pick an analysis period that is not equal to any of the useful lives.